Hello everyone. Today's video we'll be discussing the dynamic toolpath. This is my part here. I don't have stock defined yet, but let's get started. First we're going to define our stock. We go to stock setup, select bounding box, click on the part, in selection. I want to anchor to center. And I want to make the part a half an inch bigger. In X and a half an inch bigger in Y. Alright, I'm going to click lines and arcs, and what that does is it's going to create lines around the outside of the stock, and it's going to save it to a level that I created already called stock. It's going to save it to that level right there. So I click OK. There you see the lines, and there you see the stock defined, and again it's on this level here. And what it does is when I click select lines and arcs is it gives me some geometry that I can actually select, as you can see. So go to Toolpaths, Dynamic, we'll call it Dynamic here. Machining regions, we're going to select C-plane and select the outer boundary of the stock. Click OK. Select from outside as the machining strategy. Avoidance region is going to be the part, because we do not want to actually touch the part with the tool, so we're going to have the part as our avoidance region. Since the part is a solid model, I click on the solid selection and I click on the bottom boundary, which gives me a boundary on the outside part, as you can see. I click OK. Click OK. And we can preview the chain and we can see what we're going to cut. The blue represents the space where the tool can move around freely, wrap it and relocate. The hash marks will be the material removed. So we'll click OK. We'll go to Tools, select Tool, Filters. I want to select a half an inch end mill. Okay. Okay, we're not going to worry about the speeds and feeds right now at this point, because this is to demonstrate the toolpath itself. Cut parameters. We'll leave this, the step over. Okay, let's go. Approach distance is the distance you want the tool to approach the part. We'll just go at 0.5. We'll make it 0.5. And this is where you want to approach from: bottom left, bottom center, bottom right, mid right, top right. That's the position you're going to approach from. We'll leave it at bottom left. The first pass offset, if you wanted to allow for more material, you can put a value here, and it will stay away from the geometry by whatever amount you specified here. Here you can slow down the first pass feed rate, and these two settings are useful if you're maybe unsure about exactly how much stock you're going to be leaving. I mean, it's left on the material. So you can put values in here for safety reasons. The step over is a percentage of the tool you want to step over for each pass. We'll leave it at 25%. Tool pass radius. The minimum tool pass radius is the minimum radius that the tool will make as it enters and exits the cut. We'll go over micro lift distance. This is how much you're going to lift off the part to relocate. Back feed rate is the feed rate in which you wish to relocate. So we're gonna put it at 500 for our purposes. Stock to leave on walls, we're gonna leave 10 thousandths to finish, because the dynamic mill toolpath really should only be used for roughing. Stock to leave on floors, we're gonna leave 0 because we're cutting on the outside of the part. Depth of cuts we're going to leave off, because the beauty of this toolpath is that it constant chip load. So you can take a deep depth of cut, full flute length depth of cut, and you don't have to worry about binding in the corners, because it will not make sharp cuts and sharp change of directions. It will not allow itself to bury the tool into the material. We can leave this as is. It should ignore this because we're starting from the outside. When we start to do the pockets, we can mess around with these values here. Linking parameters, that's fine. That's fine. Top of stock is 0. Depth of cut will be the bottom of the part, 2 inches. And let's take a look at it. All right, now let's verify that. Great. So you can get some idea of what the approach direction is. We'll start from bottom center. So you can take a look at that. And you see it starts from the bottom center. Now for demonstration purposes, we can increase the approach distance to say, just so you can see it, we'll go 2 inches. So you can see the effect that the approach distance has. As you can see right here, it's a bigger distance before it touches the part. Again, this is helpful if you're unsure of how much material, or if you're running multiple parts and the material size varies from part to part, you won't gouge or plunge into the part itself. And that can work in conjunction with this first pass offset. We'll add a value of 0.5 here so you can get a look at how that works. It's going to start 0.5 away, and it actually will cut air because, you know, we're far away from the part at this point. But again, this is helpful if you have varying part sizes and you want to program a safe toolpath. This way it will not plunge into the part or take too heavy of a cut on the first pass or two. All right, let's change those parameters back. 0.5, 0. Great. All right. Now let's tackle the face of the part using a dynamic toolpath. So at this point, we want to machine the face of the part, and we don't want to touch this step right here, or this boss right here. Let's click dynamic. Machining region is going to be the part itself. And our avoidance region, we're going to say from the outside, and our avoidance region is going to be this boss right here. So we don't want to touch that boss. Let's preview this toolpath, and that looks good. And the blue area is where the tool is going to move freely. The red area, the red and black hashes, where is the material that we're going to machine away. We'll select our tool. We'll use the same tool. We will not worry about the speeds and feeds because we're just demonstrating the tool path. Cut parameters. Approach distance. We'll leave it at 0.5. We can go bottom center again. For some reason I like bottom left, though. It's just my preference. You don't have to use bottom left. You can use wherever you want to come from. We'll leave the step over at 25%. And again, this is based on whatever is safe for the type of material that you're cutting and the size of your cutter. So you would change the percentage to reflect whatever size step over you wish to cut or you wish to use. We'll leave depth of cuts off. Entry motion, we'll leave it off because we're coming from the outside, so we don't have to worry about plunging in. Linking parameters, that 250 retract is okay. Feed plane 0.1, top of stock 0, and now our depth will be the bottom of this step here, which is 0.5. Now let's take a look at this. There you go. Nice, even step overs, constant chip load. The tool never binds up. It never cuts more than the defined step over. All right, so let's actually verify that. We can verify. All right. Now let's tackle this pocket here. Also, now this is where the dynamic tool paths really start to shine, because we have these corner radiuses that are smaller than the radius of the tool. So we cannot get in there while we're roughing out or finishing without an enormous amount of chatter or having to slow down our speeds and feeds. So the beauty of this dynamic tool path is that it will not bind in the corners. It will not make sharp change of directions. It will make the radius. It will cut radiuses that you define in your minimum tool path radius. So let's check dynamic tool path. We want to cut this pocket here. So machining region, we'll select this geometry here in the pocket. Now, let's reselect that again. We'll select it from the top. We'll select boom, partial off here. ending here. All right, here we go. Now we have that from outside. At this point, we don't have to have a avoidance region. All we need for this tool, since it's a open pocket, is just click on a machining region, and we click from outside, and we preview chain. It looks good. Select OK. We select the tool. Cut parameters. We'll leave the same, except we can leave 10 thousandths on the floor to finish. And the reason I finish usually the floor of the pockets with a pocketing toolpath, because a lot of customers are not used to, or just don't like the way the dynamic toolpath looks on the floor. So I finish most of my pocket floors with pocket toolpaths, because the customer, again, is not used to seeing or don't like to see the dynamic toolpath tool marks on the floor of the parts. So we'll leave all of these the same as before. Depth of cuts off, entry method off, because we're starting from the outside. Linking parameters, that's fine. Feed plane, we'll say 0. Top of stock, -5. Depth of cut, bottom of the pocket, and let's take a look. And as you see, when it gets to the corners, it makes these little swirls and these little radiuses in the corner. It doesn't bind in the corners at all. Let's verify that. Actually, let's verify all 3 tool paths. We'll verify all 3 tool paths. Great, looks good. And last but not least, we'll do the pocket. We'll do this closed pocket. First we did the open pocket, now we're going to do the closed pocket. I'm just going to click here, copy, paste down below. That way we don't have to, I copied them all. Delete. Yes. Save. I just want to copy the last one. Copy. Paste. And all we have to do is reselect our geometry. This time we click stay inside because it's a closed pocket. Reselect the geometry. Rechain. There. There. Okay. Okay. Reselect. There. Okay. Okay. Preview. Looks good. Now, this is where the 0, 0, that's all the same. This is where the entry motion comes in. Helix of 250 is okay. The plunge angle, we can probably do 3. Well, if we're cutting aluminum, we can do 3, but we'll leave it at 2. And how far you want the helix to start above the top of stock. Let's just go 50. And let's take a look at that. There you see it will helix down to depth, and then it will go into its dynamic motion. We'll save it. We'll verify all 4. All right, it looks good. Now we still have to clean up these pockets. So what we can do is go to a dynamic contour, which you can use to rough and finish. So we'll select dynamic contour, machining region. We'll select last. There we go. Click OK. All of the other things we had available, all the other options we had available with the regular dynamic toolpath are not available for the contour. Only the machining region is available. We click OK. We get our tool, 1/2-inch tool, cut parameters, step over, let's go 10% for finish. Stock to leave on walls, it's going to be 0, and I'll leave the same 10,000 stock on the floor that I left with the dynamic toolpath. Back, feed rate 500, and everything looks good. Contour walls, radius of the tool that shaped it was 250. We used a 1/2-inch end mill, so the radius is 250. The minimum tool path, I believe, was 50, and we'll go and check. It's usually 10%. Well, you can set it to whatever you want, but I'm pretty sure it was 10%. And the stock on the walls that we left in the rough out is 10,000. We can leave depth of cut off. Finishing, that's finish. Number of finish passes 1 at 5,000. And compensation computer, lead in, lead out. Entry, let's go 20%. 20%. Retract 250, feed plane 0, top of stock -5, depth of cut, bottom of the pocket, planes, top, coolant. Let's go. Let's take a look at it. And oh, you know what? I got the wrong tool here. We want to finish. So we need a smaller tool, one with a radius the same size or smaller than the radius we're gonna cut, and obviously the 1/2 inch is too big. So let's select another end mill. We use a 3/8 end mill. And now let's see it work. See, now it's roughing, then it's going to go in, it's going to finish. So the good thing about the dynamic contour is that you can rough out and finish with it. It'll first do the roughing pass, clean the corners, and then it will do the finish pass. So right now this is the roughing pass, and you're going to see it's going to go back, it's going to clean the corners so it doesn't bind up. You can machine at a high rate, you can still rough out at a high rate, and then it's going to go in there and take a finish pass. Right? Now, we want to do pretty much the same thing with this pocket here. So we can copy and paste. Let's copy, paste, reselect our geometry. Click OK. Let's go. Again, you see it clean the corners, and now it's going to go in and do a finish pass. Now let's verify all. And there you have it. That concludes the video on Dynamic Toolpath. I hope you enjoyed it. I hope you got something from it. If you did, please like, please subscribe. If you have any questions, leave comments, and I will try to answer them as soon as possible. Thank you. See you next time.